Galen here, several weeks after SEMA, they were sitting with one of the electric cruisers, and as you can see, they haven't really changed since SEMA. We have been working on a lot of development issues that we knew kind of beforehand we're going to need to address, and I just want to go over some of those right now. As you can see on the computer, I've drawn some fabricated cranks, and that is one thing that we would like to change, is the whole bottom bracket and crank assembly. We want to go away from this American style bearing assembly and the one-piece crank. That's old school, nobody does that. A lot of little parts, they're not sealed. Just people that have worked on bikes know why it's not a good deal. So what we have here is a Euro bottom bracket, which is real common on mom's bike, dad's bike, mountain bikes, whatever. You can go to your local bike shop and get a new cartridge style bearing for this thing. Have your bike shop put it in, they'll have it in stock. It's a sealed unit, so it's very reliable and a lot better performance than that. So that's one thing that we're going to change. With that, we're going to go to a new style crank, just a square drive aluminum crank set, and this is actually made by FSA, so this is one that we're looking at to change. And when it's all together, resembles something that you would see on a Specialized or any big bike brand that you go and buy at a shop. So really trying to achieve that quality improvement on these areas. Another thing that was apparent with doing all these different kinds of brakes, the front drum brake is a really cool piece. We really like how it looks. We want a little bit more braking authority up there, so we're most likely going to go to the next size up. In the rear, the only thing offered to work with the gas style drive system that we were using was a very non-satisfactory band brake, so we're going to go away from that. We're actually working on a rear disc brake setup that attaches to the sprocket and actually uses the sprocket as the rotor. We have two options here that I'm working with. This is actually a rear pit bike brake. It's a hydraulic single piston caliper, the full floating pipe, and it would go on the sprocket about like this. Obviously this sprocket's aluminum. It's one that we made in-house on the fly, and it would need to be a steel sprocket of not necessarily a high carbon content, but it needs to be a decent kind of steel, just so it is a suitable rotor surface as well as a sprocket. So that's another thing we're looking at. And this will actually, on the gas version, be oriented right about here. And so it'll actually fit between the chain, and it'll be a really integrated design, and hopefully offer an awesome, very authoritative brake feel. So that'll be cool. And then another option was actually a mountain bike brake, and it's a split style design right here, so we can unbolt this, machine a spacer, and possibly do the same thing but with the actual bicycle component. So that's another thing to try, so we're gonna try that also. In addition to changing the rear brake setup, we're gonna go back to a standardized bicycle rear hub, 135mm symmetrical setup. That's what we just got in here, is this. It actually has a disc brake flange, and that disc brake flange is what we're going to be mounting our new Sprocket brake assembly off of. So that'll go on there, freewheel on this side, so it'll be a really clean setup, and should be very nice. So moving back to the cranks that I had drawn on the screen here, I showed you the electric crank, the FSA Metropolitan crank that we'd be using on the electric cruiser. The gas cruiser, because it has an engine located right above the pedals have to be wider. And before we were employing that's why we were employing the American bottom bracket, is because we could get this custom spindle that's super wide in order to cater to having a motor above your pedals. And because we are going to the Euro bottom bracket, which is skinny on both bikes, we'll need to come up with a crank that actually has a very far offset. As you can see, a crank that you would get, for a normal bike, is going to cater to really efficient pedaling. And we're going to have to make one that offsets very far out to clear the motor when you pedal. So obviously you can pedal the bike. These things are meant to be pedaled. So Right now we're looking at options for getting the weld-in pieces to fabricate a really nice crank for the caster. As you can see here, I drew it up in Inventor and also working on it in Solid Edge. And these files again will be made available online at some point soon.
How important is this CAD stuff for development of the cruiser?
It's super important. It kind of lets us standardize everything, not only for sharing with community members and people online, but also when we go from this stage of building stuff to actually making the parts. When we draw stuff in CAD, we can go back and pull dimensions off, make changes and stuff, and have a solid reference point in which everything was built off of. And of course the water jet and CNC equipment does need CAD files if parts are going to be machined or cut. To learn more on all these updates and development changes being made, go ahead and check out the Co-Create website under projects, and you will actually see all these parts and all this stuff being posted as it happens.